stack, also binary, but 0 and $, and why $? What's that for? Well, that'll become clear also. Where will it become clear? Next session. You're gonna have to wait. Right? Okay, so we'll use this $, for something, for some kind of trick, as you'll see. All right, and then a set of accept states Q1 and Q4. And you may ask why. Well, yeah, that's part of the art of being a designer. Right? When you design a PDA, which is at least as difficult as designing a DFA or an NFA. In fact, it's probably a bit more complex because you have a stack to worry about as well. And because it's a non-deterministic PDA, you can handle non-regular languages. I've got up earlier, body's not adjusted. And can you sense my brain is a bit slower? Well, I will keep getting up earlier until I've got pretty well a full daylight. I'll make use of the full daylight. That's my plan. And see if it has an effect on my eyes over a week or so. Okay. So something's missing here. We haven't done the delta yet. 1, 2, 3, 4. What's the start? Oh, the start state's pretty trivial, right? Just Q1. Okay. So the only thing I haven't talked about yet is the transition function, which is always the guts of an automaton. That's the heart of the automaton. In this case, it'll tell you what the next move is. Now, we're talking about PDA, and what's a move? So the transition function will deliver to you the next move, and that's an ordered pair. And the first member of the ordered pair is the next state, and the second member of the ordered pair is the symbol that will overwrite the top symbol of the stack. Okay, and we're still left with this question mark. Well, how do you push everything down? And if you're just going to keep overriding all the time, how do you create deeper levels of the stack? Questions like that. All right. Well, here is the transition table in detail. Oh, by the way, these blanks here, if they're blank, that's just yeah, for blank. Just read the empty set. Okay. You know, the 0 or the slash through it. That's the symbol for the empty set. So you have here empty set, empty set, empty set, empty set, and so on. Yeah. But there's so many of them. They just clutter up the transition table. This is a transition table. Okay. So your input, it's a transition function. So the domain, the elements of the domain just a set. Remember, the function maps a member of a set into a member of another set. Okay, so there are 3 parameters in your domain. So what? The current state. So that triple. Current state. The current input symbol being read. So it'll be either one of these 3. Yeah, so the binary alphabet and then augmented with epsilon. And the stack alphabet, these 2, also augmented with the epsilon, so 3 possibilities. Okay. Now it's a table, so let's say the triple that goes into the transition function is Q2 0 beta. That's your triple, your input triple. So Q2 0 eta. So your output, the transition function will deliver to you the output Now it's a non-deterministic machine, right? So the output will be a set of ordered pairs, and the ordered pair is the next move. So the output is a set of next moves, right? And a move is an ordered pair. So it'll be this. And here's your set, and there's only one next move. So effectively, it's deterministic in that case. Okay? So it's delivering, the transition function is delivering one next move, which is what? No, it was in Q2. It says stay in the same state, stay in Q2, and what's it doing here? And overwrite what the top of the stack was, which is empty. Okay, it was empty, and then overwrite it with a 0. Right, and similarly for the, well, let's do one more. Let's see. Okay, well, let's say your current triple, your input triple to your transition function is Q3 epsilon dollar. So the output, the delta function, will deliver a set of next moves. Well, there's only one move, which is the ordered pair. So your next state will go. So it'll go from Q3 to Q4. Okay, so you get a state change. And so the input is epsilon. So I guess that means we've finished reading our input string. Okay, and the next state. we will overwrite whatever's on the top of the stack by the empty string. So we'll just clear the top of the stack, effectively. Right? Now, what does this mean? Now, you've already got an intuitive feeling of how to use a PDA to recognize this language, right? The strings of this form. So I leave this as an exercise for you. Do this for homework. Get familiar with what this machine is doing. Now it's doing this, right? Now from the discussion of was it first or second? The first session on this board. The machine has like 4 actions. Either it reads a string of zeros, n of them, puts them on the stack, and then it reads a string of ones of equal length. Each time it reads a 1, it pops a 0 from the stack. So how is it popping? How is it doing that? Well, you'll deduce that from here. That's part of the homework exercise. So do this in detail, because it's your first real first detailed description of how a PDA works. So really study it, because it's not just for this particular exercise. You need the experience that you will get from this exercise to know how to have a PDA function in general. Okay, so it's a valuable piece of learning. So really study that in detail. Okay, until you understand it all and what it's doing, and like why 4 states. Now the use of this dollar I'll explain in the next session. It's a bit of a trick. And why 2 final states. Okay. Right. Now, okay. So that's the state. What would we call it? What would we call it? Well, the transition diagram, I suppose. the transition diagram. Now you can now for PDAs, and sort of next main idea, for a PDA you can still have a state diagram. So you can have circles and switching from one state to the other and whatnot. So you can still have state diagrams to describe a PDA. And well, I'll show you one at least, and there'll be more coming next board. But I'll show you one on this board next session. Now these state diagrams, they're quite similar to what you're used to with finite automata, but there's one thing different, of course, because we're now talking about PDAs, and the essential difference of a PDA compared to an FA, finite automaton, is of course the stack. Okay, so the state diagram, its arrows, the labels on the arrows will be more than just the next input string symbol. It'll be more than that. You'll need more, and well, I'll go into detail about what you put as labels on a state diagram for a PDA. It's a little bit more involved.